Alright, so welcome back to Mr. Suda's math videos, and we've been in this unit on law of sines and law of cosines, and we're going to round it out with just the area of a triangle. Might as well, you know what I mean? And ask the question. So we won't be using law of sines and law of cosines to do any area stuff, but we've been finding all the dimensions of a triangle. Why not find the dimension inside the triangle and figure out the area? So let's start with area equals 1/2 base times height. Just asked my wife. She was like, I said, what's the area of a triangle? She said 1/2 base times height. I was like, wow, I'm glad you remember that. So she's a genius. But seriously, she's way smarter than me. But nonetheless, everybody knows 1/2 base times height, right? But this really only works when you actually have a defined height of the triangle and a defined base of the triangle. So I've drawn a right triangle because that's pretty easy. So area equals 1/2 base times height, and in our picture we can see that 1/2, right, the base is 5 and the height is 12, and so then we would say area equals 5 times 12 is 60, half of 60 is 30, so we'd say 30 units, right, squared. So 30 square units would be the area of that triangle. So not a problem. However, if we move to this scenario and say, could we use 1/2 base times height? I mean, I think so, we could try. We have a base, right? So would you agree with me that the base is 35, okay? And we could say to ourselves, all right, could I find the height of the triangle? Can I do this? And do I know the height of that triangle? Could I find it, do some math? Hopefully, if you are in a trigonometry class, or pre-calc class, if I put a H here and say that stands for the height, I would hope that you'd be able to find it. So I agree with you 100%. I know you're saying it to yourself already. I love that you're saying it to yourself already. The sine of 55 degrees would equal H over 25. Right, we just kind of make ourselves a right triangle there, use some right triangle trig, and then we could solve for the height. So times 25 times 25. So now I've got area equals, and that's what H equals, right? Is this 25 times the sine of 55. So area equals 1/2 35 times 25 and the sine of 55. And I'm going to plug that into my calculator. Make sure your calculator is in degrees, and you would get that the area equals 358.38 units squared. Okay, so not too bad, right? So you could find the height, and then using some trigonometry to find the height, you could still use 1/2 base times height. In this unit, we've been doing a lot of discussion about what pieces of information we've been given about the triangle. So I want to point out to you that you've been given side, angle, side, right? And so if that's always given to me, no matter where, right, this could have been, I could have put this as A and flipped it and given you another side over on the other side. I could have done it all the way. If you think about it, you would always create a right triangle, and you'd always find the height using the sine. And if that's the case, then given side, angle, side information, I can actually just write the area formula a little bit differently, just using the sine. So here you go. So if you know side, angle, side info of a triangle, and it doesn't have to be a right triangle, right? So the last one we just did was not a right triangle. Then you can manipulate the 1/2 base times height formula like we just did, and you can do any of the following. So if you know angle A and then sides B and C, you can do this first one, 1/2 BC times sine of A. Or you can do 1/2 AC times sine of B. Or if you're given angle C, then you would do 1/2 AB times sine of C. And it's a pretty easy way. It's just a manipulation of 1/2 base times height, but it would find the area of a triangle that is not a right triangle. And so rather than going through the whole process, like you look at this example that I've given, rather than going through the whole process of finding the height and using the sine, and even in this one I'd probably have to rotate the triangle a little bit so that I could get a nice look at this thing. Rather than doing all of that, all I've got to do is use this formula. So I'm going to go area equals 1/2 And I don't really need to know what A, B, and C and all that kind of stuff. It's just going to be the two sides times the sine of the angle, as long as it's side angle side information. So 25 times 35 times the sine of 125 degrees. And you just plug all that in your calculator, and you will get yourself your area. All right, so the area, after you plug it in, would be 358.38 units squared. If you're saying to yourself, dude, that is the same exact area as the triangle up above, true, it is indeed, and you can tell me why later, but I'm not going to get into it in this video. So, there it is. Pretty easy way to find the area, right? So just make sure that you see that it's side angle side information, and you can use any one of those to get it done. Okay. There's another way that you can find the area of a triangle, and that would be using what's called Heron's formula. And Heron's formula works when the information that's given is side, side, side info, right? That's the info that you know. Whoa. And since that's the info, you couldn't really use sine, cosine, or tangent because you can't do the angle. And so there's this formula that was created, and you start here first. You start with S. And so you find this constant. S is just a constant, okay, that you need to know. It's not a side length or anything like that, but notice it's just going to be a number that we find, and it's found by adding up all the sides and dividing by 2. It's not the average of all the sides, okay? Take that, right? So A plus B plus C divided by 3 would be the average, but the S value, the constant value, is not going to be divided by 3, it's divided by 2. So you just take all 3 sides and you divide it by 2, and then you get S. And then you work your way over here. So this is where you start, number 1, find S. And then you work your way over here to this formula, and you do the square root of S times S minus A, S minus B, S minus C, and you have yourself the area of a triangle, even though it's not a right triangle. And it'll work for any triangle. Pretty nice. You just have to know all 3 sides. Okay? So let's give it a shot. Let's do 1, and let's see what happens. So find the area of the triangle. And so the first thing I'm going to do is find S. Whoops. Forgot a few letters there. Okay, so we're going to do 9 plus 3 plus 10, and then all divided by 2. You're not finding the average, so S equals, that'd be 12 plus 10, which is 22, and then divided by 2, which is 11. So S is 11. That's our constant. Right, number 1, first thing, we're finding S. Number 2, use Heron's formula. Okay, so the area is going to equal the square root of 11 times 11 minus 9 times 11 minus 3 times 11 minus 10. Alright, so A equals the square root of 11 times 2 times, what's that, 8 times 1. Great. And then you can just put that in your calculator and you'll get your answer. Okay? So with that said, I've got 13.27 units squared. Okay? And so those are a couple different ways that you can find the area of a triangle. Nothing too crazy. They're not the most difficult formulas in the world, but one of them is rooted in 1/2 base times height. The other one is this new formula, so called Heron's formula. Just make sure that you find S correctly, and then you subtract, do the difference with all the different sides, also multiplied by S, and then you square root it. All right. So I've got one just application. There's a lot of different applications we could do, but I'm just going to throw one at you. Given that a parallelogram has consecutive sides of 25 centimeters and 35 centimeters, these are like my numbers of the day, that create a 55-degree angle, find the area of the parallelogram. So I'm going to draw a picture. Always draw a picture. Gonna get a vision for this thing. Here's my parallelogram. Hopefully you are impressed. Amazing. Okay, so 25 centimeters, 35 centimeters, and this is 55 degrees. That seems more like a 55-degree angle. Okay, and we are going to find the area of this parallelogram. So hopefully you're saying to yourself, I got this. This seems like it makes sense. I'm going to do something amazing. And do not draw a diagonal line through the 55. I mean, I guess you could because you know the other angle, but I'm going to draw a diagonal line between there. I don't know what happened just there. Probably my computer. Praise the Lord for that. But I'm going to draw that. And so now you can see that we have triangles. This is also 25 if you think about it. This is also 35, and this is also 55 if you know a little bit about parallelograms, right? But this way, right, I have basically two of the same triangle. So we would probably use this area formula, right? The area equals 1/2, and then I would do 25 times 35 times the sine of 55, and that's just going to find this area, right? But then I've got another equal triangle on the other side, and so if I took this whole thing and I multiplied it by 2, I would probably have the area of the parallelogram. And so I'm just going to end up with that the area of the parallelogram is equal to 2 times 1/2 is just 1, so just 25 times, lost my train of thought, 35 times sine of 55. And hopefully that will tell me the area of the parallelogram. Hopefully that makes sense. If you disagree, let me know, but I think it'll work. And I come back from the calculator with 716.76 centimeters squared. Alright, and that'd be the area of the parallelogram, right? We can cut a parallelogram. I mean, think like you could do squares, rectangles, rhombus, maybe any quadrilateral, probably parallelogram that I could then take and cut in half into two equivalent triangles if possible. Parallelogram is probably a nicer one, and then you can multiply by 2 and you'd have your area. All right, hopefully that made sense. Hopefully you're doing well and having a great day, and all my best to you. Talk to you later. Bye.